Okay, 2-5. Transformations. This is going to call on your knowledge from Algebra 1, maybe Algebra 2, maybe even in geometry at some point, but I'm going to write recall. Y'all learned quadratics, and you learned it in the form that is called vertex form. Do y'all remember that? And you learned transformations of quadratics. You learned that if A is negative, the quadratic flips down. You learned that inside the parentheses is a number in the position of H, and on the end is a number in position of K. You learned the vertex is the numbers in the positions of H and K. You learned that inside the parentheses was a right or left movement, and then at the end was an up or down movement. Does that ring a bell? Okay, if so, great. If not, no worries. But that's what we're doing. But we're not sticking to just quadratics. We're going to also apply it to other types of functions. Come back to here, though, for all of them, because they're all the same. They're, A in the front controls the same stuff. H inside controls the same thing. K controls the same thing. The college level aspect of it is we're learning it with more functions, more types. We're also going to have, it's really hard to squeeze it in right here, a B in front of the X now, which is going to control an additional type of stretch or shrink that you probably never discussed with quadratics. So that's the game plan. There's our roadmap. Okay. The slides you will see there's 25 slides. There is not actually 25 slides of instruction. You got the cover slide. If you go to the back of your packet, the last 4 slides, not pages, last 4 slides. All right. Yeah. The last page has 4 slides on it that are extra. One of them is summarizing everything that I'm fixing to show you. So if you need a reference. The other 3 are blank graphs if you want to practice it in your textbook. I gave you some blank graphs. And I realize they're kind of small. I have some additional graph paper that I've also copied for extra practice. So the other slides are where we're actually learning the material, okay? So let's dive right in. First of all, this is the most important slide to remember your mother functions. Write it big, really big. These are the mother functions that you need to memorize. And what do I mean by memorize? I mean, if I say linear, you should know that I'm talking about x to the first power, and it's just a standard line. That's what I mean by memorizing. So this is linear right here. If I say quadratic, you should have memorized that that means x squared. And the mother function for a quadratic, meaning the parent graph, the one that starts every quadratic, is right here, directly in front of you folks, right here, sitting on 0, 0. Nothing's been done to it. It's just a standard x squared. You'll notice it has nothing else after it. No plus x, minus 4, none of that. It's just a standard y equals x squared. So this is the mother function for a quadratic. The mother function for a square root looks weird, starts at 0, 0, and then it shoots out like that. The reason it does that is because what is the square root function in relation to the squared function? How are they related? opposites, right? If you think of solving, if you're solving something that's squared, you square root it. If you're solving something that's square rooted, you would square it to cancel it out. This mother function for a quadratic, when it's reflected over the line of symmetry, it ends up right here. Don't draw this. It ends up right here, but does that pass the vertical line test? No. So the square root function has a restriction on it. Now everybody should be good at this by now. What is the domain restriction for y equals x squared, or square root of x? Has to stay greater than or equal to 0, which is exactly why only half of the curve is there. That's why it looks funny, because they're cutting off the part that would stop it from being a function. All right, cubic. This is the cubic function. The mother function is just an x to the third power. You are going to have to memorize this curve. I'm highlighting it because this is the one you really got to commit to memory. You're going to have to memorize it. You are going to hear me call this the Saturday night fever. I'll explain why in a minute. I'm really dating myself right now. This is the Saturday night fever curve. This one, right here. Write it down. I promise it's going to help. Here's why it's called Saturday night fever curve. Y'all know who John Travolta is? Okay, John Travolta had a movie called Saturday Night Fever. The cover of that movie, he is wearing these this was disco era, skin tight pants, and he has got his hips like, I don't know, something supernatural. But anyways, he is standing on the cover and he is doing this. I'm not doing the hips part, but he's got his arms like this, okay? So Ava, Connor, and Lucas, I know you can't see me. I'll show you another day. He has his arms like this. I'll pull the image up so that way they know what I'm talking about. What arm is up of mine? My right. What arm is down? My left. Look at the graph. Do you notice the right side is going up, the left side is going down? I want every single one of you right now, nobody's too proud, put your arms in Saturday Night Fever. Do it, I promise. It's going to help you memorize. Put them full out, full on.
And the cover is backwards.
All the way. I don't want any bits and yellows. Okay, hold it for a second. Hold, Jade. We're not half asking this. There you go. All right. Now you can put your arms down. Yeah, technically it's like this, but that just
It's backwards.
I guess. Yeah, your shoulders are the curves, right?
This all goes backwards.
No, it's not, because if you think about it, right? If you think of what he did to pose for the picture. Let me pull the picture up because that way the video shows it. But anyways, every time I teach this, I've had people come back and say to me, "Thank you for the stupid Saturday Night Fever thing. It helped." Or I've seen people during the exam sitting at their desk taking the exam, and they're like, I see you gonna do it. So I'm telling you, it's gonna help. I may even play the music from the movie. I'm just kidding. I wouldn't do that. Let me pull the picture. It's not backwards.
You're taking it to heart.
So you have to think about what he is, when he stood to pose for that is his right arm. So I actually am not going to copy it because I don't. But anyways, y'all, that movie, I mean, look, that was one of his, I know. It's a great movie. But, okay, so I call it the Saturday Night Fever graph, and I want want you to always think that the mother function is right arm up, left arm down, okay? Everybody with me? All right. Now, the cube root. So this is the inverse of that one. So basically, if you look at it, it is that graph, but it has been reflected over the line of symmetry that allows us to find inverse functions. And that's where it goes this way. This one doesn't come up a lot. It really doesn't, okay? So look at it, be familiar with it, understand that that's the cube root function. Those up there are the most common, and then absolute value is another one that's the most common. This is the rational function, which means it's 1 over x, and it creates a split. What is not allowed in the domain here? 0 is not allowed, which is why there is this understood invisible line right there. They can't touch 0. And then, of course, absolute value. As you did the 2-4 homework, you probably reminded yourself that absolute value functions always produce whatever's inside the bar. Now, maybe there's more in the function, like in the homework, but whatever's in the bar comes out as a positive. So it's this nice V. It's exactly like the quadratic, but it's a nice straight V instead of a curve. Okay? This slide is going to help you the most. All right. Let's dive into the first 2 types of transformations, possibly 3, depending on our time. These are the easiest ones. This is where I want to start. I want to save the ones that require more thinking for tomorrow. Okay? The first one is when you are simply shifting it up or down. It's a translation. If you go back to geometry and think to yourself, when you translate, that's where you're sliding the image. This is, I call it a shift. And you're shifting up or down. Now, this is the mother function, right? So we're going to abbreviate this with MF. This is the mother function. It's so much more fun when you're just like teetering on the line of inappropriate with the words, you know. It makes you pay attention, makes you remember stuff. This is the mother function for a quadratic. Now go to the next slide. Look at your paper on the next slide. Now look up at my screen. I left it on the last slide. Look at the difference. The next slide says what underneath it? Plus C. So this was the mother function. I'm going to the next slide now. If I wanted to take the mother function and shift it up, just pick the whole thing and go up, I would simply add a value to the end of it, to the very, very end. Okay? For instance, if you look at this exact graph, the mother function started here, and now it's here, right? So it went up by what? It went up by 2. So let's make some notes. This shifted up 2 units. Yes?
Can I please see Madeline Barnell in the doctor's office?
Yes, she's on her way. So it shifted up 2 units. So if I wanted to write the equation for the new one, the blue graph that you see here, it would be g of x equals x squared plus 2. I'm going to put EX, and we're going to just talk out loud. What are some other examples that are not quadratics? What if we had h of x equals the square root of x? Now, outside of the root, it said minus 2. That would take the mother function for the square root, and it would just go down 2. what if we had k of x equals x cubed plus 4? So that's the mother function of a cubic, and it's going to just go up 4. Down here is important. If the number at the end is bigger than 0, C comes from right there. If the number at the end is bigger than 0, it's going to move it up. So basically, if the number is positive, right? If it's positive. If the number at the end is negative, it's going to move it what? Down. So the big takeaway here, change to a different color or highlight this. The big takeaway is any function that you have, now we want this to apply to all of them, so I'm just going to put MF, meaning mother function, any one of them. It would be any mother function, right? I'm going to put plus or minus C, and I'm going to write underneath it that this means it's either up or down shift. Technically it's called vertical shifts, but I'm putting up or down to remind you that if it's positive, it's going up. If it's negative, it's going down. When I say it's self-explanatory, I mean that what you see implies what you do. Okay, so if you see a positive, you should think, you know, I'm either going up or right. Which one is it? You just need to know at the end it's a vertical movement. Okay? All right, so that's the takeaway. Now, let's look at horizontal movements. This one slide has a lot to write on it, so be careful with how big you write. Put a big asterisk right here, directly in front of you folks right here. Put an asterisk. The asterisk is to say to yourself, hold up, wait a minute. You got to do some thinking here. The thinking is that there is going to be a sign change here. There is a sign change. This is what I call counterintuitive. Counterintuitive is, it is not in the same as what you would think it would be. All right, let's refresh you. Looking at this right here, it says, hey, you got a function g of x. Look at the difference. No longer x squared plus c. Now it's x plus c in the parentheses, and then it's raised to the second power. Okay, so this yellow here is the mother function. And then the blue is showing that it shifted what direction? It went left. Now count the anchor point. I call it the anchor point. The origin point now went left how many? It went left 3. So that particular graph would be g of x equals, now here's where you have to be careful. You went left 3, which would imply what type of number? Negative, but we're in the part that I said, watch out. So it's actually going to show a positive. Make a note, asterisk, be careful. All right, let's make some more notes too. This went left. This went from here to over here, left 3 units. Now I want you, out of here, you're not an artist, you can do this. I want you to draw a big block H. Draw a big block H. You're gonna see why. It's gonna be helpful. Big block H. And then I want you to color in on the H, this is really important, just the vertical brackets. I'm calling it brackets. I want you to color in this part. I'm going somewhere with this, I promise. Then I want you to come to where there's any room at the bottom of this slide. Let me see if I can. No, I can't make that small. Okay. I'll just change. I'm going to change my pen. I want you to write, and you might want to wait until I write it all to see how big you need to write. Anything within parentheses, brackets, absolute value bars, under the radical is counterintuitive, which is Ms. Holcombe likes to say backwards. Anything that is within, this is why I had you shade the vertical part of the H, anything within parentheses, brackets, absolute value bars, underneath the radical directly is going to be counterintuitive. So what you see is not actually what's happening. It's the opposite. Now, before we move to the next slide, let's practice it. What direction did we move in this example? We went left 3. Left would describe a horizontal shift, correct? If I moved right, that would describe a horizontal shift. What does horizontal start with? An H. When you draw an H, don't you draw the 2 brackets first? No, wait a minute, right? It's the middle part first. So you draw the 2 brackets first. So I want you to think of, this is all synced together to help you remember it. This is how I remember it to this day. I know that if I'm moving right or left, that's horizontal, and I have to draw some big brackets to write the word horizontal, which tells me if it's anything within any type of enclosure, it could be parentheses, brackets, absolute value bars, underneath the radical, some type of enclosure, it's going to be backwards from what I see. Let's practice it. Come right here. Don't write big if you're going to put these examples on your paper. If you have f of x equals x minus 1 squared, don't say it out loud. Now, think to yourself, the mother function has a -1 inside the parentheses. So now, everybody, where's it going? I see -1 in here. It's going to be backwards, so I'm actually going right 1. So this would mean right 1. I'm just going to draw an arrow. Right 1. Let's do another one. H of x equals the square root of x plus 4 minus 5. Ooh, look where the minus 5 is. It's not under the radical. decide how you want to work with it in your mind. You want to either start, just read it from left to right, or go to the one that's self-explanatory. The -5 is on the very end. That means on the very end, on the end, down. Think of at the very end, I got it. When you walk into a building, like if you're in downtown Atlanta, right, you got to go to some meeting. If you walk into the building, what motion are you doing first to walk in? You're doing horizontal, right? So as you're reading this from left to right, this is the horizontal movement, and at the very end, to get to the meeting, you get in the elevator and go up or down. Okay, so the number at the very end is your up or down. All right, so I'm going to go, this means down 5, right? I should say right, correct? Down 5. What does this mean? This means left 4. It's fast backwards from what you see. All right. This slide right here is saying, hey, what if I give you an actual function and then I tell you to shift it even more? What if I give you one that's already tweaked and then I say, hey, shift it some more? Then you would just go in wherever there's an X and put that shift. This comes up one time in the homework, and I have it copied to the very end of this lesson, and I'll show it to you tomorrow. But this slide is showing you that if I give you an equation that's already got some tweaks to it, and I tell you to tweak it more, you would simply put the adjustment in with X for the function. Before I get caught up with the bell, look at this one and just say it to me out loud. That is what mother function? And where's it going? It's going down 6. Notice it's not in brackets or parentheses, right? So this is just going down 6. That is the mother function of a absolute value. It is inside, so it's backwards from what you think. You think left 4, but it's actually right 4. What about that one? That's a square root. I went to the next slide. That's the square root function, and it's going right 2. What about this one? Left 2, down 3. You starting to get them? I am going to put what I wanted on those. I know the bell's probably going to ring. This is what I wanted. This is quadratic. Shift down 6. So the mother function is like right here, right?
Hey,
So it's
wait,
going
is that leaf that didn't work?
down 6.
Every time we click
Something with my stuff?
no, somebody else. 13,000 story.
This is the absolute. Oh, it's Wednesday. I still have 4 more minutes. So let me finish the video without y'all being loud. I was trying to do this for the ones out. This is the absolute value function, and it's where did we say it's going? Right 4. So absolute value is the V. So the mother function is here, and it's going right 4. So it's going to be there. Wait,
The graph, it skips 6 and 7 for the quadratic. Like going down and going up.
It goes to 6.
wait, which one?
It looks like an 8.
It's definitely 6.
Oh no, it's just because I shrunk the slides. It's counting by the ones, so you're good. Yeah, it's going -6. It's because the the slide got shrunk to 2 and then it got photocopied in that Xerox. I wouldn't do that to you too. I wouldn't, not on purpose at least. This one we said is the square root. And it's going where?
Right.
It's going right to. Now you gotta remember the mother function for a square root. Remember that's the quadratic on its side, cut half of it off, so it's still a function. There's the mother, it's going right to. This one is the square root going left 2 down 3. So plant the mother, then go left 2 down 3. There you go. Tomorrow we will hit the remaining slides. Go ahead and start your 2-5 homework.